Welcome to my YouTube channel. Today we will learn the trick for drawing the shape or geometry of a molecule using Vsepr theory. Now before going into Vsepr theory, we should know what is meant by shape or geometry of a molecule. For example, the shape of a molecule, it is the relative arrangement of bonded atoms in a molecule. It is also called geometry of a molecule. The relative arrangement of bonded atoms in a molecule, it means how the atoms are arranged about a central atom. This we will go in details after going through the Vsepr theory. Now, Vsepr theory, the full form of Vsepr theory is valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. Now what the theory tell us all about? If you go through the books, it will give you a 2-page detailed theory of Vsepr. But here we will learn only the trick to solve the structure and to draw the structure and to predict the shape or geometry of the molecule. Now what is the main fact of Vsepr theory? Here, in order to avoid the repulsive interaction between the electron pairs, the central atom in any covalent compound always tries to keep the electron pair as far apart as possible. What it means? In order to avoid the repulsive interaction between the electron pairs, the central atom in any covalent compound always tries to keep the electron pair as far apart as possible. So what we know from our previous knowledge, that a covalent bond is formed by mutual sharing of electron. Now in any compound, say of the type AB2, AB3 or AB4, where A atom is surrounded by B atom, 2B atom, 3B atom, 4B atom. So here A atom is forming covalent bond with the B atom, and B atom are also sharing electron with the A atom. Now due to mutual sharing of electron, the central atom, that is the A atom, will have a cluster of electron pair. Now the A atom will try to keep those electron pair as far apart as possible in order to avoid the repulsion between the electron pair. Now this we will go in detail with example so that it become as clear to you as it can be. Now the order of repulsive interaction is lone pair repulsion is greater than lone pair bond pair repulsion, which is much greater than bond pair repulsion. So maximum it is the lone pair repulsion, and then lone pair bond pair repulsion, and then bond pair repulsion. Now in a molecule of the type AB2, AB3, AB4, AB5 and AB6, the A atom is called the central atom, since it is surrounded by 2B atom, 3B atom, 4B atom, 5B atom or 6B atom. Now the first case, AB2. In AB2, A is surrounded by how many B atom? 2 B atom. So each B atom is sharing an electron pair with the A atom. So B atom, A atom and then again B atom. So B atom is sharing one electron, A atom is sharing one electron, and it is forming a covalent bond. Again A atom and B atom, they are sharing electron, so they are forming the covalent bond. Okay. So you can see the central A atom is having how many pair of electron? One pair, 2 pair. So it is having 2 pair of electron. Now the central A atom can keep the 2 pair of electron as far apart as possible so as to avoid the repulsive interaction. Now in doing so, it will keep the electron pair 180 degree apart, and in that case only the repulsion will be minimum and the stability will be maximum. And 180 degree apart means the shape will become linear. Example of such molecule, BeCl2, HgCl2. Next come to the second molecule, AB3. AB3, here the central A is surrounded by how many B atom? 3 B atom. Now each B atom is sharing a electron pair with the A atom. So you can see the A atom is having how many electron pair? 3 electron pair. Now this 3 electron pair the A atom can keep as far apart to avoid repulsion. And this can be done by keeping the electron pair 120 degree apart. So the shape of the molecule become trigonal planar. So such type of molecule it is BCl3 or BF3. Next move on to the third type. AB4. Now in AB4, as you can see, there are 4 atoms surrounding the central B, 4 B atoms surrounding the central A atom. Now this 4 B atom can be placed in 2 different ways. Say this is one arrangement where the B atom is surrounding the A atom in a square planar fashion. This is square planar. Another fashion is here. Here it is a tetrahedral fashion where the bond angle is 109 degree 28 minute. All bond angle here it is equivalent 109 degree 28 minute. It is called tetrahedral, often represented by the short form TD. Okay. Now in case of square planar, the bond angle is 90 degree. So in case of tetrahedral, you can see it has higher bond angle. Higher bond angle means the electron pair is far away or much more away than 90 degree. That means in case of tetrahedral, the repulsion will be less as compared to square planar. So whenever there is a B4 type molecule, the shape will be tetrahedral and not square planar. Because in square planar, the bond angle is 90 degree and so the repulsion will be more and stability will be less. This one is more stable. So next move on to the next molecule, AB5. Now AB5, here you can see 5B atom is surrounding the A atom. So 5B atom means how many electron pair? We have seen in the first case AB2, where 2 B atoms surrounding the A atom. In that case, we got 2 electron pair around the B atom. In case of AB3, 3 electron pair around the A atom. In case of AB4, 4 electron pair around the A atom. AB5, how many electron pair? It is 5 electron pair. Now how to keep this 5 electron pair? The 5 electron pair can be kept in a fashion like this. One, two, three, 4, 5. Here the bond angle is 90 degree and this bond angle is 120 degree. Okay. The shape of the molecule is trigonal, bipyramidal. Example of such molecule, PCl5. Next one, AB6. Now in AB6, the central A atom is having 6 electron pair. Now the 6 electron pair can be arranged in a fashion called octahedral. In octahedral, there is a square base, and above the plane there is one B atom, below the plane there is another B atom, and this structure we call it octahedral, often denoted by OCT, and this is often denoted by TBP. Okay, trigonal bipyramidal. Now example of such octahedral molecule, SF6. Okay, now how we are going to predict the shape of the molecule using Vsepr theory. Now in order to predict the shape of the molecule using Vsepr theory, we need to calculate the number of valence shell electron pair. So what we have to calculate? We have to calculate the number of valence shell electron pair. Now if you can calculate the valence shell electron pair, then you can easily calculate or predict the shape of the molecule. For example, if the molecule contains 2 electron pair, then the shape is linear. If the molecule contains 3 electron pair, then the shape is trigonal planar. If the molecule contains 4 electron pair, then the shape is tetrahedral. If the molecule contains 5 electron pair, then the shape is trigonal bipyramidal. And if it contains 6 electron pair, we know the shape is octahedral. Now, one point you need to note is if the molecule contains only bonded electron pair, if the molecule contains only bonded electron pair, that is BP, it means the central atom is having only bonded electron pair, then the shape is called regular shape or geometry. Okay, now if there are lone pair, then the geometry deviate from regular geometry, and we need to find that exact shape of the molecule. Now we will be solving example where you will see how the geometry deviate from regular geometry. Now let's start with neutral molecule. For example, CH4. Then we will do NH3. Then we will do H2o. Then we will do SF6. Then PCl5, then BF3. So after doing this neutral molecule, we will do little complex molecule like xenon compound XCF2, XCF6, FCX4, then XCF6, then ClF3, interhalogen compounds, ICl5, IF7. This is one exception we will discuss, and here XCF6 is another exception that also we will discuss. Okay, after doing this neutral molecule, we will do some anionic and cationic type of molecule. For example, the common example, sulfate ion SO4 2-, what will be the shape? The carbonate ion CO3 2-, what will be the shape? The sulfite ion SO3 2-, shape. Phosphate ion PO4 2-, then ammonium ion NH4+ ion, then I3- ion, ICl4- ion. So how to predict the shape of these ionic species as well as the neutral species? So stay with me and watch the video till the end. Now, how to calculate the number of valence shell electron pair? Calculation of valence shell electron pair. So what we are going to calculate? Valence shell electron pair. So it is Vsep, valence shell electron pair. It is calculated as half into V plus M plus A minus C. Now what is V? V is number of valence electron in the central atom. What is M? Number of monovalent atom bonded to central atom. What is monovalent atom? For example, fluorine is a monovalent atom whose valency is 1. Chlorine, the valency is 1. Hydrogen, valency is 1. So they are all monovalent. But if you talk about oxygen, its valency is 2. So it is called divalent. For example, nitrogen, it is having 3 valencies. So it is trivalent. So monovalent means all those elements which has valency 1. Now come to A. What is A? A is the anionic charge. And what is C? C is the cationic charge. Okay. Now let's begin with our first molecule, CH4. Please pay attention, otherwise you will miss the important part of this discussion. CH4, what is the electronic configuration of carbon? 1s2, 2s2, 2p2. So in the valence shell, it is the valence shell. It contains how many electron? 4 electron. Valence shell contain 4 electron. So let us calculate the Vsep. So Vsep is equal to half. The valence shell of carbon contain 4 electron. Now the carbon is bonded to how many hydrogen? 4 hydrogen, and hydrogen are monovalent. So number of monovalent atom, it is 4. Is there any cationic charge or anionic charge? No. So let's calculate. So we'll get 4 electron pair. Now the question is, the 4 electron pair, it is all bond pair or lone pair? Now carbon is bonded to how many hydrogen? 4 hydrogen. That means it is forming 4 hydrogen, 4 bond. That means all the electron pair are bond pair. There is no lone pair. There we have 4 electron pair and carbon is forming 4 bond. That means all the electron pair are bond pair. Now when all are bond pair, there is no lone pair. The geometry of the molecule is regular. And for 4 electron pair, we remember that the geometry is tetrahedral. What is the geometry? Tetrahedral. See. So it is the tetrahedral molecule. Now come to the next molecule, Nh3. Nitrogen, the electronic configuration 1s2, 2s2, 2p3. So how many electron in the valence shell? 5 electron. So calculate Vsep, half 5. Nitrogen is bonded to how many hydrogen? 3 hydrogen. So 3. So it comes out to be 4 electron pair. Now out of this 4 electron pair, 3 are bond pair. 3 bond pair. Why it is 3 bond pair? Because nitrogen is forming 3 bond with 3 hydrogen. And if 3 are bond pair, then the remaining are lone pair. So how many are remaining? Out of 4, 3 bond pair. So 1 is lone pair. So we have to give the position of the lone pair. Now since the number of electron pair is 4 electron pair, the shape should be like this. That is tetrahedral. So we'll draw a structure like this. Okay. First we will put the lone pair here. Then we will put the hydrogen, hydrogen, hydrogen. Okay. Now, in any molecule, the shape or geometry of the molecule is considered as the relative arrangement of bonded atom. This hydrogen, this hydrogen, this hydrogen, and not the lone pair. So we will omit the lone pair and we will see what is the actual shape of the molecule. The shape of the molecule looks like pyramidal. So it is pyramidal. Now this lone pair, there will be repulsion. This type of repulsion we call it lone pair, bond pair repulsion. This type of repulsion, again, it is lone pair, bond pair repulsion, and because of this repulsion, the bond angle decreases to 107 degree. Here it was 109 degree, 28 minute. Now bond angle decreases to 107 degree, and the shape become pyramidal. So till now you have understood how it is becoming pyramidal. Next, wait for the next molecule. H2o. It's a very common molecule, water molecule, H2o. Here oxygen is the central atom since it is surrounded by two hydrogen atoms. Now oxygen, the electronic configuration 1s2, 2s2, 2p4. So how many electron in the valence shell? It contains 6 electron in the valence shell. Now calculate the Vsep. The Vsep is equal to half 6 plus how many hydrogen are bonded to oxygen? 2 hydrogen. So we'll add 2 since hydrogen are monovalent. So the number comes out to be 4 electron pair. Now out of this 4 electron pair, 2 are bond pair. Why 2 are bond pair? Because oxygen is forming 2 bond with 2 hydrogen atom, and rest are lone pair. Rest means it is 2 lone pair. Out of 4, if 2 is bond pair, then other 2 will be lone pair. Now what should be the shape? Since again it is 4 electron pair, the shape should be like this. The shape should be tetrahedral. Now in a tetrahedral shape, how we put the electron pair? First put the electron pair here, then put the electron pair here, then put the hydrogen here. Now here there will be lone pair repulsion, and here there will be lone pair, bond pair repulsion. And because of this repulsion, the bond angle, here also there will be repulsion, and because of this the bond angle become 104.5 degree. That means because of all this repulsion, the shape become, this bond angle become even shorter, and so it become 104.5 degree. And the shape of the molecule, now if you do not consider the lone pair, then the shape looks like bend shape or V shape. This is this type of shape. If you rotate this, you will have this V shape. So we write V shape or bend shape. So all of you understood why we write V shape or bend shape? Because here it is oxygen, hydrogen, oxygen. Do not consider the lone pair, because in geometry we don't consider lone pair. We consider only the relative arrangement of the bonded atom. Okay, let's move on to our next molecule. SF6. Now SF6, sulfur, belongs to which family? The oxygen family. So sulfur, the valence shell electronic configuration will be, instead of 2s2p, it will be 3s 2 3p4. That means again it will be having 6 electron. 6 electron. Now calculate the Vsep. So Vsep is equal to half 6 plus, now fluorine are monovalent. How many fluorine are there? 6 fluorine atom. So write 6. So we are getting 6 electron pair. Now 6 electron pair, whether they all are bond pair or lone pair, you can see sulfur is forming bond with 6 fluorine. That means it is forming 6 bond. So 6 bond means 6 bond pair. Now when there is 6 electron pair, we know the shape of the molecule is octahedral. Next come to PCl5. PCl5 phosphorus, it is in the nitrogen family. So nitrogen, it has 2s2 2p3, so it will be having 3s2 3p3. 3s2 3p3 means how many electron? 5 electron in the valence shell. So we can write the Vsep is equal to half 5 plus 5. So it is 5 electron pair. Now 5 electron pair, phosphorus is forming 5 bond with 5 chlorine atoms. So all are bond pair. 5 bond pair. Now 5 bond pair, the shape will be trigonal bipyramidal. So draw the shape of the molecule. So it is trigonal bipyramidal. Next come to our next molecule, say XeF2 xenon. Suppose you don't know the electronic configuration of xenon, and it is very obvious that you are not going to memorize the electronic configuration of xenon, but you know xenon is a noble gas. So noble gas, they contain how many electron in the valence shell? We all know that noble gas contain 8 electron in the valence shell. So it makes our calculation very easy. In the Vsep, we will write half 8 plus how many fluorine atom? 2 fluorine atom. So 2. So it comes out to be 5 electron pair. Now out of this 5 electron pair, all are bond pair? No, obviously not. Xenon is forming 2 bond with 2 fluorine. So only 2 bond pair. Rest 3 are lone pair. Now when 5 electron pairs are there, the shape should be what? TBP, that is trigonal bipyramidal, this shape. But due to lone pair, the shape will definitely change, as we have already seen. So let's draw the shape of the molecule. Now in a TBP structure, always remember that the electron pair occupy this trigonal plane. They occupy this trigonal plane. They never move on to above the plane or below the plane because of more repulsion in case of above the plane and below the plane. That I may discuss in next video. So 3 lone pair is in the trigonal plane and the fluorine atom above the plane, fluorine atom below the plane. So the shape looks like to be linear. Fluorine is a non-fluorine, so it is linear. Done. Our next molecule, XeF4. Again we have the Vsep is equal to half. For xenon it is 8, since it is a noble gas. It contains 8 electron in the valence shell, that is full octet electronic configuration. Now xenon, it is bonded to 4 fluorine atom. All fluorine are monovalent, so we will put 4. So here we have 8 plus 4, it is 12 by 2, it is 6 electron pair. Now 6 electron pair, out of 6, how many bond pairs? Since it is forming 4 bond with 4 fluorine atoms, so only 4 bond pair plus 2 lone pair. The rest are lone pair. Now 6 electron pair, the shape should be octahedral, but because of the presence of 2 lone pair, the shape will definitely deviate from regular shape or regular geometry. So first draw the basic structure of octahedral geometry, then we will put the electron pair. Now again another point to memorize, that in a octahedral geometry, when you will be putting the lone pair, you always put the lone pair either above or below. Now since there is 2 lone pair, I will put electron pair or the lone pair above as well as below, and then I will put the fluorine atom. So the shape of the molecule become, don't consider the lone pair. If you think of the 4 fluorine atom and the xenon, it looks like square planar, is it? The 4 fluorine and the xenon is present in the square planar fashion. Now this XC F6, which is one exception, then IF7, another exception. This we will do afterward. Let's move on to the next part, ICl3. ICl3, here the central atom is iodine, which is surrounded by 3 chlorine atoms. Now iodine is a halogen, and we know all halogen has 1 electron less than the octet electronic configuration. So it's very easy to write the Vsepr calculation. 7 plus 7 is the number of electrons in the valence shell of iodine, 1 less than the octet. Now it is bonded to how many chlorine? 3 chlorine. Chlorine are monovalent, so put 3, so we get 5 electron pair. Now 5 electron pair, how many bond pair? By now you know it is 3 bond pair plus 2 lone pair, means rest are lone pair. Now 5 electron pair, the shape should be trigonal bipyramidal. So we'll put the chlorine here, sorry, iodine here, and then we put all the bond like this. And now the question is, we have where we are going to put the lone pair. Just now we have done that in a trigonal bipyramidal geometry, we should put the lone pair in the equatorial position, or here you can put the lone pair, here you can put the lone pair. Okay, now you are left with 3 chlorine. Put the chlorine atom here, chlorine atom here, chlorine atom here. It looks like this type of shape. So rotate it, you will find this shape. So we can write T shape. Done. So you will get full marks. IF5. Vsep is equal to half 7 plus 5, so it is 6 electron pair. Out of 6 it is 5 bond pair plus 1 lone pair. So the shape will be octahedral. Shape will be octahedral. So put the iodine here, put all the bond. Now I told you in octahedral you should put the lone pair either above or below. So here I am putting the lone pair below so that the shape will look little better. F, 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 F. So if you remove this electron pair and if you see, it looks like a square having a fluorine atom above the square. So it is square pyramidal. Square pyramidal. Okay. Next, move on to the ionic molecule. For example, the first one, sulfate, SO4 2-. SO4 2-, we know sulfur, the number of valence shell electron 3s2 3p 4. Or if you cannot remember like this, you can remember sulfur is in oxygen family, and oxygen has 2 electron less than the octet electronic configuration. So sulfur is also having 2 electron less than the octet electronic configuration. That means out of 8 it is having 6 electron in the valence shell. So Vsep is equal to half 6 plus. Now sulfur is bonded to how many oxygen atom? 4 oxygen atom. So we will write 4 here? No, we will not write 4 here because oxygen are not monovalent. At the beginning of the video I told you that oxygen is a divalent since its valency is 2. So number of monovalent atom, it is 0. Now how many anionic charge are there? 2. So all the anionic charge you have to add. It is 2 minus, that means minus means anionic charge, plus means cationic charge. So anionic charge, net anionic charge is 2. So you will add 2. If net cationic charge is 2, then you will minus 2. According to the formula, half V plus M plus A minus C. Memorize this formula. So it is coming out to be 4 electron pair. Now this 4 electron pair, sulfur is forming how many bond? It is forming 4 bond with 4 oxygen atom. That means 4 bond pair. There is no lone pair. So when there is no lone pair, the geometry of the molecule will be definitely tetrahedral. Tetrahedral. So tetrahedral molecule, it looks like this. So put the oxygen, all the oxygen. So done. No, it is not done yet. Now the valency of oxygen is 2. Here you can see the valency is only 1. So you have to make the valency 2. Now again the sulfate ion is having 2 minus charge. So put the minus charge here on one oxygen, here on another oxygen, and the other 2 oxygen which are left without any charge, put a double bond. Done. Your structure is finished. So you will get full marks here. Now move to CO3 2 minus. CO3 2 minus Vsep. For carbon, how many electron in the valence shell? 4 electron plus oxygen. They are not monovalent, so you will add 0. Number of anionic charge, it is 2, so add 2. So we are getting 3 electron pair. Now 3 electron pair, carbon is forming 3 bond with 3 oxygen atom, so it is 3 bond pair. So the geometry of the molecule is carbon, oxygen, oxygen. Regular. Now you have to put the negative charge. Put the negative charge here on one oxygen, another oxygen. The oxygen which is not having the negative charge, satisfy the valency by putting a double bond. So the shape of the molecule is trigonal planar. Then PO4 3 minus. PO4 3 minus. I think you can do it. If you could not, then in the next video I will show you how to draw the PO4 3 minus. You try yourself, it is very easy. And then NH4 plus, it is also very easy. Let's move on to the 2 problematic place, that is XCF6. XCF6, it is half 8 plus 6. So how much it is? 7 electron pair. In my Vsepr theory discussion, I haven't told you what to do with 7 electron pair, and so it is a drawback of valence shell electron pair repulsion theory. So valence shell electron pair repulsion theory cannot predict the geometry of the molecule XCF6. The geometry which I am going to tell you is actually the crystallographic geometry, and it is like this. Xe is here. It is having a octahedral shape with 6 fluorine atom, but here 7 electron pair, where 6 bond pair plus 1 lone pair. So where to put the lone pair? The lone pair is protruding outside from one of the trigonal plane. So you can see the trigonal plane, it is the X-ray crystallographic structure. It is called distorted octahedral or monocapped octahedral. Distorted octahedral or monocapped octahedral. Next, it is the last molecule, IF7. Again, it is half 7 plus 7. It is coming out to be 7 electron pair. Now 7 electron pair, all are bond pair. So the geometry of the molecule will be like this. So it is pentagonal bipyramidal. Bipyramidal. So this was our last molecule. So if you like my video, please share with friends so that they also get the knowledge of Vsepr theory, how to solve the theory, and don't forget to subscribe my channel. Okay, bye.